In working with ratios, you will often have to use your skills with fractions. Simplifying fractions into their simplest form is an important skill. So is generating equivalent fractions. In this video, we'll look at equivalent ratios and compare ratios to see if they are equivalent. Let's look at an example. One math class has 14 boys and 16 girls, while another class has 15 boys and 18 girls. Which class has a higher ratio of boys to girls? Here we are looking at two ratios, but in each case, it's a similar type of ratio, boys to girls. Let's look at class 1. The ratio of boys to girls here is 14 to 16. But 14/16 as a fraction is not in simplest form. In simplest form, it's 7/8. Now let's look at class 2. The ratio here is 15 to 18. But 15/18 is not in simplest form either. In simplest form, it's 5/6. We need to compare 7/8 and 5/6. The least common denominator for 8ths and 6ths is 24ths. For class 1, the equivalent ratio expressed in 24ths is 21/24. For class 2, the equivalent ratio expressed in 24ths is 20/24. As you can see, class 1 has a higher ratio of boys to girls. Any ratio can generate equivalent ratios by creating equivalent fractions. Let's look at another example. This is a right triangle with side lengths of 4, 4, and 4 square root of 2. Is this right triangle similar to a 45, 45, 90 degree right triangle? In this example, we have a right triangle whose sides are in the ratio 4, 4, and 4 square root of 2. The question is whether this triangle is similar to a 45, 45, 90 degree right triangle. These types of triangles are in the ratio 1, 1 square root of 2. So is 4, 4, 4 square root of 2 equivalent to 1, 1 square root of 2? To generate equivalent ratios with three items, multiply each term by the same number. So let's try multiplying this ratio by 4. The results are 4, 4, 4 square root of 2. Which is what we're looking for. So this right triangle is a 45, 45, 90 degree right triangle. Let's look at one more example. At a car dealership, the ratio of smart cars to mid-size cars is 2 to 9. The ratio of mid-size cars to SUVs is 5 to 2. What is the ratio of smart cars to SUVs? This is a situation where two separate ratios need to become a three-item ratio. When we construct the smart car to mid-size to SUV ratio, then we can find the ratio of smart cars to SUVs. We want to generate this ratio. Smart car, mid-size, SUV. We know that the ratio of smart car to mid-size is 2 to 9. And we know the ratio of mid-size to SUV is 5 to 2. If we can generate equivalent ratios so that the value for m is the same for each one, then we can construct our three-item ratio. So start by creating equivalent ratios to 2 to 9, and then equivalent ratios for 5 to 2. When you find equivalent ratios that have the same values for m, then you have found the equivalent ratios to allow you to create the 3-item ratio. So generate a list of equivalent ratios for 2 to 9 and then for 5 to 2. What you'll find is that the ratio for the smart car to midsize ratio, you'll find 10 to 45. And for the midsize to SUV ratio, you'll find 45 to 18. This ratio 10 to 45 is equivalent to 2 to 9. This ratio 45 to 18 is equivalent to 5 to 2. Notice that the middle term is the same, 45. So now we have the terms to create the 3-item ratio. What we end up with is 10, 45, 18. This means that the ratio of smart cars to SUVs is 10 to 18, which can be simplified to 5 to 9.